So, hello everyone, and welcome to our weekly session that we conduct, Ask AuxEn Anything. And as you all know, that this is an online platform for civil structural engineers to interact with us and ask their doubts or queries that they may have related to any RCC or steel design project that they are doing, or any conceptual clarity regarding any conceptual doubts or construction site related issues. So, this is the 77th such episode that we are conducting. And let us begin by taking the queries that have been asked for this week. So, first we will start by taking the queries in the Google form, and then we will take the queries from live audience. So, the first question is from engineer Raghu K. He is a working professional from Bengaluru, and he is asking, uh, in a box culvert with a cushion design for calculating vehicular live loads, should the effective span of the culvert or dispersed effective length be used? I don't know. I don't have much of an experience working on box culverts, although we have done box culverts, but I don't have experience, codal experience, so to say, where I know the codal provisions or the codal landscape when it comes to box culverts. And then his next question is there any specific Indian code for design of box culvert? I think IRC 6 gives all the detailed requirements for the load calculations, vehicular load calculations, uh, that are required for any structure, any structure on which vehicular load is expected. So I guess IRC 6 is the code. But is there any specific code for box culverts? I don't know. Okay. Yeah. Next question is from uh, engineer Ritesh Kumar. He is a postgraduate student joining from Surat, Gujarat. So he is asking, I'm a student of MTech, second year structural engineering in Surat. I want to do my dissertation related research topic on IS 11384, including ETABS as my software. Can you suggest me some topics on which I can work on that can be completed within 6 to 8 months? And will this course be useful for me? So, research topic for composite structures. Maybe you can work on fully embedded beams in RCC, because over there is no codal provision as such for fully embedded beams in RCC slabs or in completely in RCC. So maybe that is what you can work on, or you can work on uh, shear connectors for columns, because our Indian standards don't clarify that in great detail. Shear connectors for columns, for composite columns, that is. Maybe this is one of the topic you can work on. Some basics of some formulation for this, because Indian code is not giving you much information about the uh, composite column shear connectors. You can also think about working on composites shear walls. So although this, in composite shear walls inside an RCC shear wall, we embed we embed a steel plate web and flange. So this is the plan view I'm showing you. So let's say this is the shear wall length, and this is the plan view. This is the thickness. So we embed a steel cross section inside the embed a steel cross section inside the shear wall, and this is called as the composite shear walls. So there is not much information, or rather, I would say that composite shear walls are not covered in the 11384 as of now. So maybe you could try to do some topic based on this. You may explore this more. Okay. So I guess these types of topics you can think about. For other topics, I'll think and I'll get back to you that which other topics you can work out from IS 11384. So, uh, intuitively, or I would say to my mind quickly, these topics I could think of, and I'll think more and get back to you for this question. Will this course be useful for me? So, in this course that we are soon going to start next week, it will be a course on composite design, composite structures, wherein we are going to cover composite beams, columns, composite slab design, uh, shear connector design, etc., etc. And that will be based on IS 11384. So, if you want to understand IS 11384 and be able to use it on software like ETABS, etc., then yes, this course will be useful for you. Okay. All right. So this was engineer Ritesh with his query. Now there are no more queries for this week and no more queries in the email also. So if live audience has any query, we can take them up now because there are only two queries, two questions asked in the Google form for this week. So now if you have any query, live audience, you may now ask. Yes, please. Any query from our live audience? So we will wait for a couple of minutes to see if there are any questions or queries. Otherwise, we will be, I mean, we'll be able to finish today's session because Google form queries I have taken up. Naz STR is asking in typical steel warehouses with half wall clad and half block wall. What is the load path of wind on block walls and steel columns? See, usually when we have such a thing, uh, what we do is if I show you the plan view, that this is my, let's say, RCC pedestal. Okay, I'm showing you the plan view right now. This is my RCC pedestal, and this is again my RCC pedestal, and this is my steel column in plan view. Now the block walls, there are two options. Either we place the block wall like this, okay, but then it eats up the space of your warehouse, effective space available in the warehouse. So what we may do is that we may shift the block wall outside. Now when we are going to shift the block wall outside, I can extend the pedestal slightly more, and I can take it outside the steel column line. So typically your brick wall line will be outside the steel column line. This is one of the ways in which we provide block walls. So the thing that I want you to understand is that this block wall is not physically connected to your steel structure. Okay, not connected. So in cross-sectional view, how it will look like that you will have your steel column, and it's going, let's say, up, and then you have a block wall, but that block wall is free and not connected to your steel column. So let's say this is my block wall, and maybe up to, let's say, 3 meter height you have taken this block wall, and then beyond this you have put your cladding. So this is your cladding line. So now what you need to understand, that what will be the load path. So for wind loads, usually what we do is that we will consider the wind acting on the sheet after 3 meters. Okay, so you will consider that the wind load is acting on the cladding after 3 meters, and that wind load will transfer to your steel structure. For the wind load that is acting on this brick wall, because this brick wall was independent, we will assume that this brick wall, the wind load on this brick wall will be transferred to your ground beam and the pedestal below. Now that pedestal and ground beam are so large in size that they will be easily be able to take those wind loads, and you need not worry about it as much. So you need to only bother about the wind load that will act on this cladding after 3 meters or whatever is your block wall height. So no wind load from block wall, you need to transfer it to your steel structure, because essentially we try to keep block walls and steel structures unconnected. So wind loads after 3 meters you can transfer it. So if you were, let's say, making any analysis model, computer model, what you can do, that you apply the wind loads after 3 meters on your columns. Okay, so up to 3 meters no need to apply any wind loads. After 3 meters, you 3 meters is right now the block wall height considered. So this type of analysis model you can create. Okay, all right, I hope this answers your query. Mr. Venkatesh is asking, how can I efficiently group and design steel connection for multiple joint locations in Idea Statica without designing each one individually? See, it will depend. In case one, what you could do is that you could, just a minute, I'll just use the same image that you had shared with me. Wait a minute. So this is the image that you had shared, and you are asking that how to efficiently group and design steel connections for multiple joint locations in Idea Statica without designing each of them individually. So see, one of the strategies could be that, let's say, you had these three different connections. So you had connection one, this was your two, and this was your three, let's say. Okay, now let's say that these were typical, these orange beams were of one size. Okay, and then these green beams were of a different size. Now one of the ways is to uh, design the connection for the member capacity. So that means that whatever is the moment capacity of that member, suppose the moment capacity of this beam, I'm not saying the analysis moment, I'm saying the moment capacity. Okay, the resistance that it can offer. So if you were to design this cross section for the design moment capacity, sorry, if you were to design the connection for the design moment capacity of the beam, not the analysis moment, then basically what it would mean, that wherever you have this beam, okay, wherever you have this beam, you can provide a typical connection. So if this was, let's say, ISMB, just taking an example, 400, so wherever you have an ISMB 400 connecting into your steel column, you could just use the same connection. But this is not a very economic solution, because obviously uh, our analysis moments are usually lesser than the design moments, and if I am providing the connections for the design moments, it would mean I am going on the conservative side for my connections. So it may not come out to be the most economic solution that way, but design wise it would be very efficient. It would require least time on your part, isn't it? The second approach can be that, let's say, these were analysis moments, different beams having different analysis moments. Okay, because maybe the loads are different, whatever is happening, different analysis moments. You run your analysis in ETABS or STAT, and you look at the load combinations. For different combinations, you have got different results. So what you do, that for this green colored beam, whichever was the highest analysis moment in the entire model, let's say mu3 was the highest analysis moment, so you design your connections for mu3. So each connection, every connection where you have a green colored beam joining into your column, you will provide the same connection assembly corresponding to mu3. Now this will again be slightly conservative because it may happen that the moments were variable. That means mu3 was quite large in magnitude, mu1 was smaller, mu5 was even smaller, and so on. But then it will be design wise, it will be efficient. Even fabrication wise, it will be efficient, because please understand that connections are very time consuming on site. Fabrication wise, assembly wise, connections are uh, quite time consuming and difficult to execute. So if you come up with a lot of different types for your connection, they will not be, they may not be the very efficient way of doing it. So you may think that for mu1 I will provide one connection type, for mu2 moment I will provide another, for mu3 I will provide even different. So that strategy will lead to six different connections, let's say for six different beams, and that I would not suggest. So what can be your different strategies? You Strategy one could be that you design all your connections for moment capacity directly. Okay. Second strategy could be that you design for the highest analysis moment. And third strategy could be that for each a member, depending on the moments and shears, of course, you design the corrections individually. Okay. So any of these three strategies could adopt. I would recommend you to do either this or this. Uh, this does not make sense. The case three does not make sense. Okay, because that will lead to just too many connections which you cannot provide on site, or you cannot just fabricate so many different types of connections. So either use strategy one or strategy two. Mr. Venkatesh is saying, in that case, can I design the connections considering one joint at one side? Question not understood. Question not understood. One joint one side means? This question is not clear. Okay, so in the meantime, he is asking a follow up. I'll just take the other query that has been asked. So, uh, NAS S1R, he's asking, he or she, I don't know. The question is, what is usually the design procedure for slab on grades? If you model on safe with area springs, soil subgrade with uniform area live loads, just minimum reinforcement tends to govern. Yeah, that's true, because slab on grades, the design philosophy is similar to what you do for rigid pavements. Okay, so Westergaard's approach we do. You can read any good book on rigid pavements. The same concept is used for slab on grade design. So because your slab is resting on grade, that means your slab is resting on compacted fill, we are not assuming, or there is negligible bending moments that your slab will experience. and that is the reason why your reinforcements that you will find will not be that high. So therefore, uh, as you rightly pointed out, that the minimum reinforcement usually will tend to govern, but you need to be careful about the soil compaction over here. What is the proper K value that you want to achieve from your compacted fill is what you need to understand and ensure it on site, that you are able to achieve the appropriate K value. Okay. Uh, so the Westergaard's equation is used for this, and then temperature related stresses. If generally slab on grades, we don't consider temperature because slab on grades are inside our, let's say, industrial complex, so they are not going to be subjected to temperature variations as such. So temperature is not an issue, but you may have to consider corner stresses and all those things. So slab on grades is, the design is similar to the Westergaard's equation. You could look for some documents that you can refer for slab on grade design. One of them is your British document, which is TC09. Okay, so there is this British. No, it is TC09 or it is TR34. No, TC09 is an Indian document, Industrial Flooring Applications by Indian Concrete Institute. Okay, you could search for this TC09 on industrial flooring by Indian Concrete Institute, and this document has been taken from a British document by the name of TR34. Okay, so this is another document that you could refer to, TR34. This is a British document based on concrete floors, industrial concrete floors. So the design philosophy for slab on grades is well covered in these two documents. This is an Indian document which largely derives from TR34, and then there is the original TR34 document. So these are some of the additional learnings that you can, or additional readings that you can have. Okay. Okay, Mr. Venkatesh is having a follow up. He's saying, instead of considering four beams on one column for connection design, just considering beam connecting to column flange in one design, and then, yeah, that could work. That could work. See, because let's say in plan view, if I have this column, if in plan view I have this column, this beam is on this side, and you are coming up with a connection type for this, and then there is another beam on this side, and you have to develop a different connection for this. So usually, see, there is this problem that the moments and shears on this side of the column may affect some of the local elements like web, when the connection on the other side is also created, and when you apply forces moments over here. But generally, because this side is your web, and on web you are anyway going to give a shear connection only, so with shear connections it's not much of a problem. So you could develop this connection individually, and this connection individually you can develop, no need to model all of them together. And then of course their combined effect is getting covered in your overall analysis model that you have prepared, let's say on ETABS or STAD or whatever. So the overall effect of the two beams joining from two sides and their moments and shears, etc., is anyway getting covered in your main analysis model. So I would say yes, for connection, this type of a connection where you know that one of them is going to be a shear connection, you could model these connections one at a time. That means you prepare one model where you just make this connection, then you prepare another model where you prepare this connection. If you had moment connections both sides, then I would have suggested you that at least make one combined model where you have both the beams connected, The forces again, which force and moment to put, that you need to decide from your judgment. Okay, looking at the realistic possibility that the forces and moments in this beam for the same load combination, what is the forces and moments in this beam and so on. So that judgment you may have to think based on your case. So if it's a moment connection from both sides, you may at least make one model where you model both the beams or whatever, how many number of beams you had, just to see what is happening on the entire column. Also, any local issues if you could find out. But otherwise, if only if you have moment connections on one side and shear connections on the other, one at a time, modeling one connection at a time can only be done. Okay, all right, good. Then there's another question from NAZ S1R. Rod bracings for the structure in PV structures usually connect to column web using hillside washers. I have never seen anyone check local stresses in that column web. Actually, the check for column web stresses is not covered in the Indian code, especially for this type of a connection, as you are pointing it out that in plan view, this is your rod bracing and it is connected to your column like this. Okay. Now, checking for local stresses, I do agree that nobody checks it because there might be situations where there is a this type of a deformation that may happen. And there is another problem that may occur, which is called as the torsional buckling of column. Because in elevational view, if you see, this is your column, this is your web, and there is this, let's say, bracing connected, rod bracing connected like this. So one component of force will be downwards, and if that force is at certain eccentricity from the center, let's say your bracing was connected over here in plan. So because of this eccentricity, there is a situation which can create torsional buckling in your columns. So there is a formula given in the AISC 360 for this check also. When you go to design of compression members, they have given you a formula for torsional buckling checks, so that you also need to consider, plus the local stresses in column webs also should be considered. I agree that they should be done. Usually they are not, but yeah, you should check. Good point. Mr. Venkatesh is asking, how do we design FRP composite wrapping around the RCC column for retrofitting? I don't know. I have never done it. You most of the times there are literatures that the FRP these retrofitting agencies, the material that you are using, those material producers provide technical documents which structural engineers use. But other than that, how to exactly do the design, I don't know. Okay. Because you will need to know the tensile resistance, you will need to know how much of how much of compression resistance they are able to add to the concrete. Then you will have to calculate the increased capacities and all those things. So I'm not sure how that calculation is done. Anything else? Yes, thank you, Naz.S1R. Mr. Naz is asking, wouldn't Mr. or Miss, I don't know. Naz is asking, wouldn't that beam, wouldn't that wind load cause a lot of torsion in the ground beam? Yeah, technically it would, because those beams are connected to your pedestals. You could do an exercise and just find out that due to this wind load, how much of a torsion is getting generated in the beams, and see if that magnitude, how much of that magnitude is coming. See, generally many of the engineers, design engineers, what they also consider, that anyway you are having a ground slab connected. Okay, you are going to have a ground slab connected, and that ground slab will be, let's say you can integrate it with the beams. So when you do that, then the effect of torsion will be reduced as such, isn't it? Even these ground slabs that are provided, they are also considered to be effective in providing lateral restraint to your pedestals also. So if you consider presence of ground slab, then the torsion in ground beam, or the effective so the moment sorry the if you consider the effect of ground slabs, then you can consider them to be providing effective restraint to ground beam as well as pedestals. So it's not a big issue that way. But your point is valid that if not for the ground slab, there might be substantial torsion that you may see in these ground beams. Mr. Venkatesh is asking, in bracing design, even gusset welded plate connected with member by welding will be. Huh? In bracing design, even gusset welded plate connected with the member by welding will be considered as a pinned case. I've not fully understood the question. In bracing design, even gusset welded plate connected with the member by welding. Usually, all sort of bracing connections can be taken as pinned, even if we are not making actual pins, because of the thin gusset through which we are connecting them. So the gussets themselves have very little moment carrying capacity, and that's why it's a valid assumption, I would say, to consider them as pinned. So in most of the cases, because of the way in which we connect the bracings, they have very little moment carrying capacity, the gusset connection. So it's a I would say a good assumption to consider them as shear connections only without transferring moments. Okay, good. Any other query anyone has? Yeah, so it can, you could consider it as shear connection only for all practical purposes. Okay. Any other query anyone has? Only two people have been asking. Nobody else is having questions. So all of you know that every weekend we conduct this session. You can join us live on every weekend. And thanks a lot for your appreciation. So every weekend you can join and ask your queries. So the Google form, throughout the week also, if you have questions, you could just put them up in the Google form. The link remains the same, and you can keep on putting your questions in the same form. And then when we meet once every week, you could we will take up your questions, right? So that way, even during the week, if you have any doubts or queries, uh, you will not forget them means it will not we will not miss out, because you have already put your query in the form. And then once every week when we meet, now you know, all of you know the timing for it. So then you can join us live and see your questions being answered. And even if you are unable to join the session live, You could always watch these sessions later on, and because your query is there in the form, we would have taken them up. So that way you can save your time also and make this entire process efficient. So this is the link for Google Form which you can use for putting your queries. And if you want to connect with us on WhatsApp directly, this is the link to connect with us on WhatsApp. Yeah, this is the link. So I think that's all for this week then. Thank you very much for joining, and keep putting your questions. Next week when we meet, we will take up the questions as we do always. Uh, have a good weekend and have a good week ahead. Thank you very much. Bye bye.